Okay, A3 is graphing of rational functions, graphs of rational functions. We've started graphing rational functions. We did it in A2, right? Like we plugged numbers in, we made our chart and graph things. And you either had graphs in quadrant 1 and 3, or in quadrants, 1 and 3, or 2 and 4, right? Okay? And we shifted, what?
That's kind of scary.
I know, but it's not. I'll explain it in a second. And we shifted our asymptotes according to what was going on, correct? Okay, so here's the deal. There are basically 3 rules we need to talk about for our asymptotes. The ones we did earlier were simple because if it had something added or subtracted to the x on the denominator, that was my domain and my horizontal asymptote. What? Yes. And if I had something added or subtracted on the outside of it, that was my range or my horizontal asymptote. Yes? Okay. So we're going to talk about what it looks like when I have like some x squareds up in here and some different stuff going on. Okay. So first one is this. When we are graphing rational functions, we want to, number 1, find the x-intercepts of the graph if there are real zeros and we want to graph those, okay? P of x, meaning what's on top, we want to factor out if it's factorable and mark our zeros on there, okay? Step 2 is that you want to graph, the graph of f has a vertical asymptote at each real zero. So you graph those zeros so that you can make a vertical asymptote, okay? Step 3 is that the graph of f has at most one horizontal asymptote, which is determined by the degree of m and n. Okay, so here you have x to the m power, x to the n power, yes? Okay. What it's saying is, if the power on top is less than the power on the bottom, your horizontal asymptote is always y equals 0. So if the top power is less than the bottom power, my asymptote is always y equals 0 for horizontal, okay? If they are equal, we did this already, you take the leading coefficients, put them over top of each other, and that's your horizontal asymptote. If the top power is larger than the bottom power, okay, it has no horizontal asymptote. There's none. Okay, which means we get a graph that looks like a bell curve or something like that. We get something a little bit differently. Okay, so that's how I find my horizontal asymptotes. Those 3 things. Okay, the first one is if m is less than n, if the power on top is less than the power on bottom, it's always y equals 0. If the powers are equal on top and bottom, I do the leading coefficients over top of each other. And if the power on top is greater than the power on bottom, there is no horizontal asymptote. So we're going to just graph a bunch of stuff today and state domains and ranges. Okay, graph y equals 6 over x squared plus 1. So y equals 6 over x squared plus 1. How would I want to start graphing this? No. The first step was what in our last slide? Find the asymptotes. The first step says the x-intercepts of the graph, meaning the zeros of the top. What's the 0 of this here? Is there an x-intercept?
It's on the bottom.
No, so are there going to be vertical asymptotes on this one? No. Okay. So the numerator has no zeros, so there is no x-intercept. The denominator has what?
2.
Well, sort of. If I set x squared plus 1 equal to 0, I get x squared equals negative 1. Is that a real 0? No, because if I take the square root of negative 1, I get plus or minus I, correct? Okay, so it has no real zeros either. Okay, so then we need to talk about what that means. The degree, the next thing we need to look at is the degree. The degree up here, is it larger or smaller than the degree down here?
Smaller.
Smaller, because there isn't any, right? So what does that mean my horizontal asymptote is?
0.
What?
Y equals 0.
Yeah, y equals 0. So my horizontal asymptote is y equals 0. So I'm going to come here, and it's not going to cross over that. So what do you think I need to do from there?
Wait, what was the whole thing about the x-intercepted crap?
When you do the top part and find the x-intercepts, it gives me my vertical asymptotes.
Oh,
If I do the bottom and there's vertical asymptotes also, but there are none in either case, correct? Okay, so all I have is a horizontal asymptote right now, but I need to discover some stuff, okay? How can I figure out from here what I do next? What do you think you need to do?
okay, nice.
Plug in numbers to x, okay? So let's plug in some numbers to x. Let's do this. Let's plug in easy stuff. Let's plug in -3, -1, 0, 1, and 3. How's that? Okay. If I plug in -3, what do you get on bottom?
10.
Yeah, 10. So you get 6/10, and 6/10 reduces to
3/5.
3/5. If I plug in -1, what do you get? 6/3.
2, 3.
Okay. If I plug in 0, you get
1,
6/1. So,
6,
and if I plug in 1, you get 6/2.
2,
So you get,
3.
and if I plug in 3, you get 6/10 again. So you get
3/5.
3/5. Okay. So look at this. -3,
That's a parabola.
sort of.
It looks like
-3, 3/5, okay? -1, 3, right? 0, 6, 1, 3, and then negative, or positive 3, 3/5. You get what looks like a bell curve.
Yucky.
So it's gonna ride that. So if I have no vertical asymptotes, I'm going to get a bell curve.
it's a mountain.
I'm gonna just get, I'm gonna get a mountain. Okay? Because it's mirroring itself, it's reflecting over that axis. Okay? Now, domain and range. What's my domain?
The x up.
Can you plug anything into X and get stuff out? Yeah, it's continuing forever both directions, yes? So what's that domain?
Infinity.
And well, -infinity to infinity, or we can say all real numbers, either way is fine. Okay. What is my range? How far it travels on the y-axis. So what can it not cross? Let's start there.
0.
So 0 is less than y, correct?
Mm-hmm.
But y is less than or equal to what?
6.
Good, because it hits its peak there and comes back down, correct? So that's as far as it's traveling. So here are the things that we have to identify. Asymptotes, domain, and range. Okay, so you have to do a little thinking there. It's not quite super hard thinking, but a little thinking.
That's too much.
I'm sorry. Now, let's look at another one. Y equals 3x squared over x squared minus 1. How do you think we start graphing that?
It's
Find the
x-intercepting.
The zeros of the numerator, we need to start there. The zeros of the numerator. How do I find zeros of a numerator?
just look at the end.
Good, solve for x. So how do I do that? Set the numerator. 3x squared equals 0, so x squared equals 0, so x equals. So what is my vertical asymptote?
0.
Yeah, it could be 0 on this. So, the 0 of the numerator is 0, so 0 is an x, well, actually it's not an asymptote, it's an x-intercept. That's how I find my x-intercepts. Now, what do I have to do with the bottom part to find my vertical asymptotes?
Power
No. What do I have to do with my denominator to figure out what the vertical asymptotes are, not horizontal?
They're equal.
It's the same thing we did last week. What do you do with the denominator always?
The powers.
Nope, that has to do with my horizontal asymptotes, not my vertical asymptotes. What do you always do with the denominator? We did it right here. Yeah. So x squared minus 1 equals 0. So x squared equals 1, which means x equals what? Nope. When you take the square root of something, how many answers do you get?
Oh,
So plus or minus 1. These are my vertical asymptotes. So look, you're used to having 1 vertical asymptote. How many do we have now? 2. So watch this. Last week when we did this, we graphed in quadrant 1 and 3, or 2 and 4. Now you're going to graph in 1 or 3, 2 or 4, and in the middle. Okay, we're going to talk about what that looks like. Now, my last step is to set up my horizontal asymptote. How do you figure out your horizontal asymptote? No, it's not. Look at that equation. What do you know about the power up top and the power on the bottom?
they're the same.
So what do?
Is a divide.
Divide what?
Divide
I want the horizontal asymptote. Just like last week, guys. Just like last week. I need you to remember. Listen. When the powers are the same, what do? No.
Divide.
You put what over each other?
Oh,
Okay, kind of.
3 over
Not
1.
the x squared. You put the
Just
leading
difference.
coefficients.
Just the
Yeah.
difference.
Okay? So horizontal asymptote is 3 over 1. Okay? Which means it is 3. So my horizontal asymptote is 3. So I come to 3 and I make this horizontal asymptote. So look at this. I'm going to have a graph here, and, well, it's going to look different, okay? Here I have a center. I know I'm graphing in this center because that's my x-intercept, yes? 0, 0. Okay? So here's what happens. When you create this, I create now 6 sections, yes? Okay? You have to graph in 3 of them. So here's how it looks. You either graph in the top, bottom, top, or you graph in the bottom, top, bottom on these. That means you have to plug in more numbers than you did last week. I've got to plug numbers in from this section, and from this section. Okay? So I'm going to plug in, let's do -3, -4, -3, -2. Here, this is 0, 0, which means I've got to plug in fractions, -½ and 1/2. And then I'm going to plug in 2, 3, and 4. Okay? So this takes longer because you have to plug in more. You have to, because this is in the middle here, this x-intercept's at 0, 0, and there's an asymptote at -1 and an asymptote at 1. So you have to plug in fractions, and I think 1/2 is the easiest one to choose.
What is the point of the x-intercept that we did at the very start?
That is the x-intercept. It tells me that my graph is gonna be in this section. So my graphs are gonna be here, here, and here. Okay, sometimes I'll get more than one x-intercept, which is really nice, because then I'll know more numbers and have to plug in less. Okay, so now I'm gonna plug in. If I plug in a -4, okay, -4 squared over -4 squared minus 1. What's -4 squared? So 16 times 3 is what? Should be 48, I think. And then this is 16 minus 1, which is 15. And what's 48 divided by 15? I would do,
3.2.
good, yeah. I would give decimal answers if I'm you, because it's going to be easier in the long run, okay? So we'll plug in -3 now. What happens? What do you get? 27 up top. What do you get on bottom? What's 27 divided by 8?
3.4.
Okay. Plug in -2. What do you get up top? 12. On bottom you get 12 divided by 3 is?
4.
Good. Okay, I'm gonna graph this just for a minute to show you stuff. So the -4, 3.2, which is perfect because my asymptote is at 3, so it comes straight over there, yeah. This is 3.4, which is a little higher, and this one is 4, which goes here. So this is what this graph looks like. That section, okay? Looks good so far, it's like the same thing we did. Now plug in -1/2. What's -1/2 squared? Not 4, 1/4. And what's 1/4 times 3?
3, 4.
0.75. And then what's -1/2 squared here? 1/4, right? What's 1/4 minus 1? -3/4. So you get what here? So you get -1. So what do you think this is gonna come out to be? No? -1 also. Because remember, it mirrors it. So you get a graph that looks like this here. What type of graph is that? A parabola. So you're gonna have a parabola in the middle ones. Or you're gonna have, if there isn't a horizontal asymptote, you'll have an S shape, like a cubic function. Okay, so you'll have a parabola if there is a horizontal asymptote, and if there's not, you're gonna have a cubic function. Okay, what do you think 2 is gonna get us out? Be smart. 4. What do you think 3 is gonna get us out?
-3.4.
Not negative, just 3.4, it's gonna mirror it. What's 4 gonna get us out?
3.2.
Okay, so listen, save yourself some time. Be smart, okay? Just plug in some of the numbers and save yourself time. So 2, 4, this is here, and this is here, and your graph looks like that, yes? Now, I need domain and range. I already have my vertical and horizontal asymptotes. Domain is what? What's your domain? It is not all real numbers. You have asymptotes.
Are there gonna be multiple domains?
Oh, yes.
It's gonna be something like.
You can write it in a way like this, if you want to.
It's gonna be like X cannot be something.
Yeah, X cannot be what? What can they not be?
X cannot be, 0.
No, it's not. X cannot be 0. In fact, X is 0. It's a 0 intercept. It's an intercept. What did you say it cannot be? Good. X cannot be positive or -1. So, X cannot equal plus or minus 1.
Y cannot equal +3.
Y cannot equal 3. There's your domain and range.
So smart.
Okay?
So it's just however many asymptotes are, is however many.
Definitely, yes. Okay, here's another one. This is y equals x squared minus 2x minus 3 over x minus 4. Okay, first thing is I need the x-intercepts, which comes from where?
Top equals 0.
Okay, if I set equal to 0, what do you have to do?
FOIL.
Yeah, factor it, yeah? Yeah, so I wanna say x squared minus 2x minus 3 equals 0. So I ask myself, what multiplies to give me -3 and adds to give me -2? 1 and 3, what's positive, what's negative? Beautiful, so then x equals 3 or, and those are my intercepts. So 3 is an intercept, -1 is an intercept. Got it? We will work with those later. Okay, now you need to find your vertical asymptote. Yes? How do you find vertical asymptote?
Is that the powers?
Nope, that's horizontal, vertical.
Leading
equals zero?
So
coefficient.
the bottom equal to 0.
Oh.
X minus 4 equals 0, which means x equals 4, vertical asymptote. Okay, so I come over to 4, and here's an asymptote, yes? Okay, now tell me horizontal asymptote.
The top is greater than the bottom, so that's y equals 0, or
No.
y is greater than 0?
Uh-huh.
No.
If the top is greater than the bottom, there is no horizontal asymptote. Okay, so your graphs are gonna look interesting, okay? What that means is this, my graph is gonna look, and I'm not gonna draw it right now like perfect, we'll plug numbers in, but it's gonna look like this, it's gonna come and turn kinda sideways, and come and turn kinda sideways, because there is no horizontal asymptote, there's only a vertical asymptote. So let's plug in numbers, we need to plug numbers in on this side, right? And on this side, we already have 2 here, so I'm just gonna pick this one because it's in between them, to see if it's going up or down, does that make sense? Okay, so x, y value, my x value is 1 that I'm gonna plug in, and then over here I'm gonna plug in, what is this, 5, 6, 7? Okay, so let's plug that in. If I plug a 1 in, you get 1 minus 2, right? Minus 3, which gives you what? 1 minus 2 is -1, -1 minus 3 is -4. And on bottom, I would get 1 minus 4, which is -3, which would give me 1 and 1/3, correct? Yes? Okay. So if I graph 1 and 1/3, I get something like this. So this graph is going like this. It's curving here, okay? Now let's plug in 4, 5, and 6. 4 squared is, or I'm sorry, 5. 5 squared is, and 25 minus 10 is,
15.
minus 3 is,
12.
and then 5 minus 4 is
1.
1. So you get 12 over 1, which is
12.
12. Let's plug in 5, or 6. Gosh dang it, I can't talk. Okay, 6 squared is,
36.
and 36 minus 12 is,
24.
and 24 minus 3 is,
21.
and 6 minus 4 is,
2.
and 21 divided by 2 is,
10.5.
and 7 squared is,
49.
and 49 minus 14,
35.
and 35 minus 3,
32.
and 7 minus 4, and 32 divided by 3,
10.7.
10.7. Okay, that's interesting. So I have 12, which is like up here, and then I have 10.5, right? And 10.7. So I got a graph going like this. Okay, domain. What can x not equal?
3 or -1?
No, just
Oh,
4.
wait, yeah, sorry.
And my range?
0.
What's my range? My range is my y. Can it go up and down at any number? So, all real numbers, because there is no y asymptote, correct?
Why is there numbers plugged in from the other side of the thing?
What? You
plugged in numbers from the other side of the
from this
line.
side?
No, from the other side of the line.
This?
Yeah.
Because you have a vertical asymptote, you have to plug numbers in on both sides of your vertical asymptote.
But you didn't graph anything over there.
Yes, I did.
Oh.
Miss, how do you know which numbers to put on one side and which?
You pick numbers from both sides of this line. It doesn't matter which ones, you just need to pick 3 from both sides. So that I can see it curve, you know what I'm saying? Okay, so pick 3. Okay, read the word problem. Carissa, what's it say?
A food manufacturer wants to find the most efficient packaging for a can of soup with a volume of 342 cubic centimeters. Find
Thank
the dimensions of the can that has this volume and uses the least amount of material possible.
Okay, so how can I do this? How do you find the volume of something that's a can, a cylinder? Do you know the formula for that? Let me give you the formula. How about this? Volume equals pi r squared times your height, I believe. Right, because pi r squared is a circle, and then you have to multiply by that. Okay? So if we know that, what can I do? Plug what in?
342
Where?
to the volume.
To the volume, thank you. So 342 equals pi r squared h. What do I do from there? Divide by pi, is that what you want to do? Okay, so if I divide by pi, but wait a second, what's it asking me to do? Find the dimension of the can that has the volume and uses the least amount of material possible.
So wait, is that gonna end up being area then, since it's?
Good question, sort of. Here's what I would do if I were you. I would make this so that the equation's rearranged so that it says the height equals. And here's why. So I would divide by pi r squared, okay? Because what is pi r squared?
Circle.
It has to do with the circle, right? Okay. And we know a circle has, pi r squared would be the circumference of a circle, correct?
Yeah.
The circumference? Or are you talking, or is it the area?
I think that's the area of the circle.
Is it an area? Circumference is
2 pi r.
2 pi r.
Yeah.
Yeah, you're right, it's the area of a circle, okay? So what I need to do is figure out what the surface area of something is first to go from this, okay? Do you know how to find surface area?
Of a cylinder?
Yeah, of a cylinder. Chris is like, no. And this is where the lovely internet comes in handy. So surface area equals 2 pi r squared plus 2 pi r times the height. Okay? And here's why I transferred this into h equals, because we're gonna substitute this in to that h there.
Oh, I got you.
So you get surface area equals 2 pi r squared plus 2 pi r times 342 over pi r squared. Yes? Okay, so what happens is pi r cancels, leaving you with just one r, yes? Okay, so you get 2 pi r squared plus, and 2 times 342 is 486, yes,
684.
over r, okay?
Wait, isn't that 2r?
Yeah, would it be too?
No, because I multiplied 2 times 342.
But are you distributing? Cancel.
This has a 1 underneath, you can't distribute that to the r. Does that make sense? Okay, and this is as far as you can take it, because here's the deal, you would need a graphing calculator to figure this out without, or you could spend hours trying it, okay? But this is what they're getting at. When I get that equation down to there, then I can plug in numbers and test things out, okay? That is what we're working on tonight, graphing